Hello. Hello. Thank you very much. Hands up who uses Terraform? Almost everyone in the room. Everyone else just in here just to chill out? Excellent. So I have 6 slides in total, and I decided to be adventurous and build a provider live on stage. So we may have some typos. We definitely have lots of live snippets so that I don't have to type everything. But fingers crossed, we should be good. So there's a current list of Terraform providers. There are so many of them. Every time I've found and spoke to people about Terraform, they've always said, yes, but it doesn't have that provider. And Terraform have great contributing guidelines to get started, so I thought it would be really easy to show you a really simple way of getting started with Terraform and writing some providers. So no more slides. We're just going to go straight to the code. I'm using IntelliJ just because I have the live plugin snippet providers that I can use, and then I can drop them in, and it'll auto-create my code for me. Just to prove that this doesn't work right now, I'm going to create the Pingdom provider. Okay, it's a very basic implementation of Pingdom, but you can see that I've declared a provider, and I've declared a resource, and I've passed in some variables inside, and if I Terraform plan, it will tell me provider Pingdom not found. So let's go and fix this. First thing we got to do is we're going to create a bin for it. What this bin will do is this will allow us to build the plugin while we're developing it. In 0.7, Terraform changed the way it built its binaries, and everything is now one binary, which makes it a lot faster and a lot more efficient. But while I'm developing, I still like to be able to build the individual plugin to check that everything works as expected. So we're going to call it provider Pingdom. And in here, we're going to create a new file called main.go. Now, I have a tiny snippet of code that does a few things. Firstly, it just registers that there is a provider and that is going to be part of the plugins. And the provider is called Pingdom, and it sits in the package main. So really simple, really easy, no problem. Now, we leave the bins and we go straight to the provider. Again, we're going to create another directory, and we're going to call it Pingdom. And inside Pingdom, we're going to create a file called provider.go. Now, provider.go is where we're going to specify the schema for how the provider itself works. So things like passwords, usernames, certificate strings, whatever you need for a provider goes in provider.go. And I have provider schema, a tiny snippet of code that will do that for us. Excuse me, that wasn't in there. So this does a few things. I'm using the schema.helper right here. I believe pre-Terraform 0.4 or something like that, everything had to be manually created. Okay? You didn't have a schema helper, which made it very difficult to keep consistency across providers. And the lovely core maintainers have implemented schema.helper, which means that we can very easily have a look at what it does. So if I go and have a look at, I'm just going to turn on my file watcher 1 second. Go imports, perfect. Excellent. Okay, so if I go inside the provider, I can see, come on, that it has, oh, wrong one. I can go inside the actual provider itself. This is the schema.helper. So we take the schema, we take a resource map, we take data structure map, and you can configure the func. Okay, so this is very basic, the basic way that every provider is put together. It doesn't do anything too bad here. Now, from here, we're going to configure the provider. This basically creates a connection to the SDK. If I didn't break the template. There we go. That's much better. So this initializes the Pingdom SDK. It takes in some variables. The variables in this case are API key, password, email address, and it will read those from environment variables somewhere. Possibly. Let me do that one again. Pingdom schema. That's the one I needed. So inside the schema, I can say pingdom schema, and it will drop in that my variables are right here. And it takes the email address, the password, the API key, and you can either specify them in the provider or you can specify them as environment variables. From there, you have a resources map, which we don't have any yet. And we actually we validate that the credentials are all existing. And from there, we get our Pingdom client, which is based off a password, an API key, and an account email. So if I go back, plug in dev, provider Pingdom, it's going to do a quick compilation of the provider right now. And it's going to actually have changed, allowed me to initiate the provider configuration. And if I now Terraform plan, it says, change the error. It says the provider doesn't support the resource Pingdom check. Excellent, we have a provider. First provider, really simple, really easy. This code that I've written took about 20 minutes to write. There's nothing hard in that exact piece of code. When you get into the individual resources, they change slightly more and they become dependent and difficult dependent on the resource itself. So let's go and build some resources. So we are going to create a resource, Pingdom check. .go. The most basic functionality of Pingdom, creating a single HTTP check for a given amount of interval on a URL. Really simple. And from here, we are going to create a resource skeleton. Now, this is where helper schema comes in for us. Helper schema gives us the CRUD functionality, the basic constructs of what it needs to be. So we take a schema, which will be a list of variables that we can apply to our check. It takes a version if we need one. It can migrate some state. But the most important thing is it has create, read, update, delete, and exist functions on their API. Now, this allows us to use and abuse each of those methods to do the things that we need. Yesterday's keynote, it talked about the import stuff. Importer is also in the helper schema. So you can write your imports in the same way, in the same checks and resources that you would as before. So let's go back. From here, I have a schema. And the schema has ID, it has name, it has resolution time, it has whether the check is paused or not, it has a URL and a port to run it on. Okay. Now, of course, I don't have anything in any of my methods. So if I go and have a look at the create method, all it does is it just returns the read, and the read just returns nil, because I haven't written the functionality around that right now. So we create an instance of the client. Go away. We create an instance of the client. We then create a pointer to HTTP check, which is a construct inside the client. We give it a name, a resolution, paused, host name, and port. We create the check. We error if nil, or if the error is not nil, we error out. Otherwise, we set the ID and then read the values back. Anyone who's looked at the Terraform code, this is the bog standard way of we do it. Okay, this is exactly the way it happens. It goes create, read, or update, then read, and then sometimes it actually goes create, then update into read, depending on whether it needs to be a put or a patch operation, and so on. This is as simple as it can get for Pingdom right now. So let's create the read. These snippets will be available if you want them. I don't really know what use they're going to do to anyone. This is just demo code, but you can have them if you want them. And right now, what we do is we take the ID back that we've created and set it in the state file as the ID. We convert it back to an int because Pingdom, for some reason, wants ints via their SDK rather than strings. We go off and we read the check. If there is no check, we error out. Otherwise, we set the values into state to make sure that there is no recurring plan between runs, between Terraform runs. And then lastly, we'll implement the delete. And again, we convert the ID into an int. We'll log it just to make sure that we're actually going to tell people what's happening if they have log level switched on. We delete the check, and we error out of nil. So let's make the plugin again. Now, if we go and Terraform plan, we'll see that it just errored out on us because it says it doesn't support the resource. We need to tell the provider that the resource exists. So we go into the code, back to provider, and in our resources map, we say ping them, check, and that resource points to the resource of ping them check, which is just pointing to the top level function, and it takes care of it inside. We do one more build. You can see why I want the plugin build, because otherwise to build the whole binary every time, it would slow me down. So I like to be able to build in a lot faster way. And we Terraform plan, and we actually can set some stuff. Great. So let's just prove that this doesn't exist in Pingdom right now. Pingdom. Anyone use Pingdom? A few people. Great. This is relevant. We would have known. So I have no checks. No checks in here right now. And I have created a very simple check, which is called hashconf.eu. It's not paused, and it's just going to point to Google, just to make sure that it can actually resolve Google and that the check works as expected. So we can Terraform apply, and it shouldn't fail. Maybe. Excellent. It says it's added the resource as Terraform would do normally. And we go and refresh the UI, and we have a Pingdom check. Fantastic, right? This is like, how long did I know I typed the code up in advance. There's maybe 150 lines of code there in total. So it's really simple to get going. Now, there's a few things to note here. Let's go back to the presenter mode. In the resource, I've only specified a create, a read, and a delete method. Okay. Dependent on the values that you get as part of the schema, helper schema will help us understand the operations that we have to do. For example, if the resolution could be updated as we go through, we could change that from force new, or we could just remove the force new true, and we would have to implement the update command. So let's try it, and I'll show you what it does. And we build again. And helper schema actually has given us some validation in a really good way. It says, hey, you know, the validation has failed. There's no update defined, so therefore all your values must have force new. You didn't have this pre-helper schema. This is what's made it so much easier to implement these providers. And everyone will have providers in their company in order that they don't get mainline support from Terraform. You can go and write this really easily and load it in. So let's undo that work. Let's plan just to make sure everything looks as expected and no changes. No changes required. So let's destroy it. No? So this is easy. Now, there are some contributing guidelines in the Terraform repo. Okay, they're usually the top sort of level 3. Okay, code must be like formatted to Go standards, so run and Go format across your code, no problem. Secondly, it must have acceptance tests. Okay, because we need to know that the provider runs on a nightly basis when the Travis instance picks up our code every night. So let's go and add some acceptance tests to this. The acceptance testing framework for Terraform is amazing because it actually will create instances in whatever provider you tell it to. It will then connect to those providers and check that it has been created as expected. So if you write an AWS test, it's going to go off, create something in AWS, then make a read request or a get request in order to actually work out if something is there and has it been successfully created. And it will tell you if there's a recursive plan in there by saying, you know, that's going to force a new resource, so that's going to fail every time that you try and roll Terraform out. In order to do this, we need to create a provider test. So provider test.go, because our acceptance tests need to understand the requirements of the provider. So email address is set, password address or password is set, and the API key is set. So we have a really simple way of doing that right now. And of course, I have another snippet of code for that, provider test. And this is the same for all providers. Okay. What it basically says is it initializes the provider. In this case, we're initializing a pingdom provider, and then it does internal validate. So it does the equivalent of making sure that I have set all my update operations correctly, or I haven't set something to be forced new when it's in the update. The schema helper will do that for us. And then lastly, we have one more. We have pingdom provider test. And this is just a pre-flight check before our acceptance tests to understand if the specific environment variables that we require to run the test are set. So in this case, we need an email address, a password, and an API key. You're going to have to take my you're going to have to take it from me that they exist in my command line. I have been guilty before of opening up my ZSHRC file and showing people that they exist, and I've had to completely kill all my keys and start again. I'm not going to do that this time, because it looks silly when I do. So we are going to create one more Go file. Resource, pingdom, check, test.go. Now it's going to be very similar to its construct as before. Okay, we need to declare a test. Basic check test. And this is the standard way that we would run all of our providers tests. So you declare a resource, or a test resource in this case. You have the pre-check. That pre-check links back to making sure that all of our operating system, all our environment variables are set as expected. We have the provider itself. We have a command called check destroy. We'll come back and look at that one in a minute. We have a config, which is the specific config that you want to test and check that it works as expected, which in our case here relates to this resource right at the bottom. So you've got the name, you've got paused, you've got resolution, you've got URL, and you've got port, exactly the same configuration that I ran from my command line and from my own Terraform file. And then lastly, you have a check. So you write a check function to understand if it has been successful in applying. This is where it actually goes off to the cloud provider and does the get request for you. So let's implement these last two functions. So there's our check destroy. Check destroy in this case, it's almost identical to the code for get in the main resource. So we take our ID, we convert it to an int. We then go off to the API that we've created a client to. We read the check. If it errors out, we return nil. It means that it doesn't exist, and we don't really need to worry about it too much. But the main thing is, if the response is nil, then we want to say, hey, if the response is not nil, it means that there is a resource still out there, and we haven't destroyed it. Our destroy is not working as expected. And the last snippet is exists, and it's pretty much the inverse. So you're taking the ID, you're converting it to an int, you're passing it into the pingdom API. If the error is not nil, we fail, and if the check is empty, if there is no check returned from the API, we error out at that point as well. Anyone use IntelliJ? So they've got some new cool features in IntelliJ that allows you to run the tests, so I don't have to remember the command line options. We've got this little button right here called Run Tests, and we're going to try and run it and see if it works as expected. Excellent. So the test ran. Great. And if we go into the pingdom resource check, and we run that test, that test was ignored. So we're going to go and run that from the command line. Make test accept. In fact, let me just make this bigger for you to see. Make test accept. So there's a makefile target for this that you just pass variables into. We want to build the provider for pingdom, and the tests that we want to run are test acceptance pingdom basic check. And if we execute that, please don't fail. It's starting to run the check. And it's passed the check. So it only takes 11 seconds to run the check. That's actually spinning up the resource in pingdom, checking that it's there, destroying the resource again. If I go back to pingdom, you'll still see that there's only one test in. You'll see that it hasn't left any dangling resources in there because it's cleaned up after itself. Okay. So the code for this is pretty simple. Up until maybe 4 months ago, I didn't know any Go. So this is all learning from the Terraform core maintainers, because every time you submit a pull request, they're helping us understand the code. So they're feeding back on good formatting guidelines, they're feeding back on better testing strategies, and it's a great way of being able to learn a new language. And if we just go one more time and just have a look at the steps that it would have, okay? So you declare a provider. That provider will have a schema. The schema in this case is the variables required to run it. Okay, that's the same as going to the Terraform file. And in here declaring, so we have to say email address equals such and such, and we say password equals something else, and we say API key equals something else. So it's reading them from the command line, so we want that ability. It's not great to be able to put passwords in Terraform files. Please don't do it. Please. From there, we configure the provider, and we connect to the client or the SDK that we require it to connect to. And then lastly, we declare in the resources map the providers that we actually want to support, the resources that we want to support within that provider. So in this case, it's pingdom check. The next one could be something like pingdom page speed. And you could go off and do that. So you can declare as many as you want, and they can be as granular as you want them to be, depending on your own scenario. From there, and we start getting into the guts of helper schema. Create, read, update, delete, exists. That's the 5 actions on helper schema. So you can use a mix of them, you can use none of them, you can use whatever ones you want, it doesn't matter. So we're actually going to go, and we're going to do update. Resource, pingdom, check update. Just going to grab the interface. Update will return into the read function just to make sure that it's actually going to specify the information back to state. And then from here you can say if d.hasChange, and in our case we're going to have the resolution time. And what that's going to do is, in the update command, it's basically going to say, if there is a change to the resolution parameter, then do the action, and then read the information back. So here we would probably say, you'd have a client, and you'd have an ID, And we would say response error equals client.checks.update. It takes the ID, and it also takes a new check struct. So let's go and create that. And so on and so forth. So you can very quickly start very small and start expanding quite well. Now, before you go and create lots of providers, there are lots of open requests in GitHub for providers. There are a lot of work in progress requests. Go and have a look and see if there's something that you can help out with. Go and have a look and see if there's something you can contribute to and help get some of those providers over the line. And just to go in through the contributing guidelines. The most important thing is it says right at the top, if you're unsure or afraid, just ask. Okay, basically, the guys are fantastic in the community. The Terraform community is a really good community to be part of. It's really easy to they push a lot of code back. Unfortunately, I'm responsible for like 2 of the providers in the list right now. So if there's any errors in them, I apologize. I'm not going to tell you which ones they are, just in case. But the contributing guidelines will give you a list of everything. It'll tell you about which ones are the HashiCorp providers. It'll tell you which ones are the community providers. It'll tell you how to report bugs. It'll tell you how the issue lifecycle, pull request, etc. The main thing is, it has a lot of information right at the bottom about how to run acceptance tests. Okay? Acceptance tests are the most difficult part where people get stuck on to start with. They're like, if I have to write acceptance tests, how do I do it? What is the best way to approach it? Obviously, they will cost a little bit of money if you're spinning up instances or databases or ping them checks or something like that. So you'll need a little bit of credit in an account if you're running them locally. But when you contribute them back, you can speak to the guys and they can see what they can do. And then lastly, it has good information on how to write and documentation. Documentation is extremely important. I don't know about you, but I get very, very frustrated when I try and use an open source project on the internet and the documentation is poor. When it has incorrect or incomplete information, it makes it very difficult to use. A really good way of getting around that is if you find a bug, fix it, send a pull request. It's a great way to get involved in the community. Any questions? Hold on, they're just going to bring a mic.
Going from the back, actually, similarly.
Sure.
Okay. Working with APIs is dodgy because you're using other people's stuff, rate limiting and all that kind of stuff. Does Terraform itself provide management for rate limiting of requests if you get stuck by that, or do you have to write that support yourself? So
I think the question is, does Terraform have the ability built in to do the rate limiting, or do you have to manage that yourself?
On the assumption that exists for all the providers that you're working with. Ultimately.
Unfortunately, you have to manage that yourself because a lot of vendors are very different in their rate limiting. So AWS has got a little bit of an easier hit than, say, Azure, which has a lot more network requests happening. So you would have to take care of that in your own provider, unfortunately. There's one up here. He's coming up.
Yeah. If I write one of these, how do I share it with my team? If I don't want to wait until it hits the main branch?
Interesting. So the question is, if I write a provider, how do I share it with my team before it goes back into the main branch? Is that right? So I technically don't know if this has changed since 0.7, but I'm pretty positive. I'm trying to remember a name of a provider on the internet right now. An external? Joyent? This one? Ah, there we go. So there's some great documentation built in on how to do this. Did you say the history? Yeah, this is it. So you would have in your local machine a file called Terraform RC, and inside that Terraform RC, you would declare a list of providers, and you would push a path to where those providers are. So if you distributed the binary amongst your team, you could then have that on like your local machine or a network share, and then just point out, and you would be able to take advantage of that from your local Terraform setup. But it's very important to understand here that if a provider was built against a specific version, and you're not running that version, the chances of it working are a little bit less. So 0.7 is in RC right now. The new provider stuff, if you're building against that, may not work with the 0.6 work. Does that make sense? Yep. Okay. Any other questions? Excellent. I thank you all for your time. Contributing guidelines are on GitHub. Go and have a read of them. It's actually very interesting to see how people do it and how they expect the code to come back. If you send code that is written against the guidelines, it gets merged a lot faster because it's easier to get into the main system. So try and follow them if you do send it. And if you spot something in the system, open an issue or a pull request. People love seeing issues and pull requests coming through. We have no more questions. My Twitter handle is right here. If you have any questions, you want the code, anything like that, please get in contact. It will all be available. And thank you very much for your time.